In the last class, we saw different parts of a pneumatic control valve. Now let us see classification of control valve. There are different ways in which we can classify the control valve. One is based upon the type of actuator. Based on the type of actuator, we have three types of control valves: pneumatic, hydraulic, and electrical. Under pneumatic actuators, we have two types: spring and diaphragm type of actuator and piston cylinder. In hydraulic, we have piston cylinder type of actuator. Under electrical, we have motorized and solenoid. Solenoid is on-off type of control valve. Now the power that is generated by hydraulic actuator is the highest, so it is used for driving heavy valves. Then the medium force is generated by the pneumatic actuator, and most of the control valves, 99% of the control valves are pneumatic. The force generated by electrical actuator is less, and it is not recommended for hazardous area. Now, depending upon the valve body, there are various types of control valves. Most commonly used is globe valve. Globe valve is of two types: single-seated and double-seated. Later on, we will see the details. Now, here there are two categories: vertical sliding stem and rotary valves. Ball valves and butterfly valves are rotary valves, and remaining ones are sliding stem type of control valve based on the valve body. Now, based on the action, we have air to open and air to close, which we have already seen. When I say air to open, it is air failure to close. Suppose if through the control valve steam is flowing and that steam is used for heating, then it should be air failure to close. In case if there is a cooling water which is passing through the control valve, it should be air failure to open. So if air fails and the control valve opens, the cooling continues. Now, depending on the type of characteristics, control valve are of these three types: linear, quick opening, and equal percentage. Characteristics of control valve is the graph of percentage opening versus percentage flow. Now, this graph depends upon the shape of the plug. So here we can see different shapes of the plug. This is for quick opening. This shape of the plug is for linear characteristics, and this shape of plug gives us equal percentage characteristics. These are the three natures of the graphs for the control valve characteristics. Quick opening is on-off type. For a linear characteristics, the percentage flow is directly proportional to percentage opening. So if it is 50%, the flow is 50%. If the opening is 40%, the flow is also 40%. For equal percentage, we can divide the curve into two parts as shown by this line. So below 50%, the slope of the curve is less, and for this part of the curve, the slope of the graph is steep. Now these are the equations for linear control valve and equal percentage control valve. Now there is one important term, that is rangeability. Rangeability is the ratio of maximum flow to minimum flow. Now the graph which is drawn over here, those are theoretical ones. Those are not practical ones. So these are inherent characteristics. That is when the pressure drop across the control valve is constant. But when you actually install the control valve in the pipeline, the pressure drop is never constant. So the nature of the graph is different than the way it is drawn here. Those are called as installed characteristics. That is when the pressure drop varies. So how the pressure drop varies? So let us take an example. So here we have a pump which is pumping water into this pipeline. There are a number of elements in the pipeline. So we have orifice, control valve, then we have a pipeline which will cause friction, and that will cause a pressure drop of PF. Then we have a heat exchanger, then it goes to a column. Now as the flow through this pipeline increases, this frictional loss increases, and that is why the pressure drop available across the control valve decreases, because this PP is going to remain constant, that is the discharge pressure of the control valve. So as the flow increases, the frictional losses will increase, the pressure drop across this control valve will decrease, and that will decrease the driving force, and so the flow characteristics, they change. Now when the pressure drop is not constant across the control valve, then equal percentage starts behaving like linear, and linear starts behaving like quick open. Now guiding is nothing but aligning the movement of the plug with the seat. Plug should properly move in and out of the seat for perfect closure of the valve. So if there's a gap between the plug and the seat, then there will be leakage. So to align the movement, we have guiding. There are three types of guiding: top guiding, bottom guiding, top and bottom guiding. So here we have top guiding pictures where we have a plug and a stem. So to align the movement of the plug with the seat, there is a ring that is, or guide, that is provided surrounding this stem, so that the stem does not deflect sideways and the plug properly fits into the wall seat. So since there is no rod like extension beyond the plug, we cannot have ring both on the top and the bottom side. So this is just top guiding. Now here you can see the plug. There is a rod like thing on the top of the plug and the bottom of the plug. So we can place a ring surrounding the wall stem on the top part and on the bottom part, so that the plug will not deflect sideways. So here there can be top guiding and bottom guiding. Yeah. So here are some more photographs for top and bottom guiding. Now if the guide is there in the plug itself, then it is called as port guiding. So you can see stand like things which are connected to the plug. They are seen clearly over here. So these studs, okay, just below the plug, help to align the movement of this plug with respect to the seat. So this is port guiding. In the next class, we will see different types of control valve based on the valve bodies.